so there's different ways that we measure temperature, and this is the one you're most familiar with, right? It's just a thermometer. Mercury in it, as it heats up, the mercury rises. This is actually your maximum thermometer. It tells you the maximum temperature in the room or the area. And this is a minimum thermometer. It works the same way, except instead of mercury, it's alcohol, and it's horizontal. And it tells you the minimum temperature in the room. Now, we don't usually have these minimum thermometers. We don't usually have these minimum thermometers in the room. Maybe if you're doing something specific that needs it. I've never actually seen one in person. And then, so this is a thermograph. It looks like a lie detector, right? It kind of like the drum and then the needle, and as you lie, this needle just kind of goes nuts, right? And it does the exact same thing except with temperature. As temperature changes, the needle goes up and down. Alright, now there's 3 different temperature scales we use: Fahrenheit, Celsius, and Kelvin. And they'll have a kind of interesting history. At least I like to think it's an interesting history. Fahrenheit actually does have an interesting history. It was the first one to come along. However, its story is kind of weird. Also, America is the only one that uses Fahrenheit. Everywhere else uses Celsius. So it's still kind of strange that we still use it. But it was the first one, so there is that. And what Fahrenheit did is he said, okay, ice melting, that's going to be my coldest point, because who really wants to get colder than that, right? And so he set that to 32 degrees. And then his highest one, you think it's where water boils, because that's what the picture shows, but no, it's not. His highest one was his body temperature. Now, we all know body temperature changes, right? His body temperature was 96. I run at 98. My daughter runs at 97, right? So this was not repeatable. So that's why it got later changed to steam, and that ended up being 212 degrees Fahrenheit. So then Celsius came along, and he made centigrade, which we're all lazy, so we just say Celsius. He's like, look, Fahrenheit, I love what you did. Like, putting a number to hot, cold, warm, and cool, that's a great idea. However, I don't like your numbers. I mean, let's be realistic. Nobody likes Fahrenheit numbers. And even though we use it, we don't like it. Okay, try and subtract. Go ahead. 212 minus 32. Well, you're not done yet? You get to think about that? Come on, right? 2 minus 2 is 0. Easy. 1 minus 3, oops. And a lot of us just go oops and stop there. But you're supposed to carry or take the 1 from the 2, so that makes it 11 minus 3. That makes 8. Right, and then 1 minus 0, because 1 is the only one left out of that 2. So you're looking at 180. And Celsius is like, look, dude, I went 2 minus 2, 1 minus 3, duh, stopping. Right? So let's see if we can change those numbers. So that's what he did. He's like, okay, water freezes, I'm going to call that 0, right? That's going to be our coldest point, that's going to be 0. Water boils, that's 100. Okay? And so what's 100 minus 0? 100, right? You didn't even need to think. So that's when Celsius came along, and so a lot of, well, basically everyone except the USA went, hey, that's a great idea. I don't have to think. Not thinking is good, right? So we're all switching to Celsius. Then you get Kelvin, and he's kind of like the nerdy guy in the class that nobody likes. Not that we have one in this class, because everybody likes each other, but Kelvin was kind of the nerdy guy. So he's like, look, guys, I like what you did, but really you're going to call 0 water freezes? Why? That's kind of arbitrary. I'm like, well, because we don't really want to get any colder than that. And he's like, yeah, but you know it does. I was like, well, yeah, we know it does, but we don't want it to. He's like, yeah, but you know it does. Yes. So what he said is, look, temperature is how fast molecules vibrate, right? And they're like, yeah. He goes, okay, so why don't you call the point at which molecules stop vibrating 0? And so then it ended up calling that absolute 0, because there's absolutely no motion. They're like, okay, I see your point. You're kind of right, but we don't like it. Because what happens? Well, if you call that 0, then water freezes at 273. Okay. Celsius is like, oh, come on, Kelvin, like you're going back to those weird Fahrenheit numbers. And he's like, yeah, but water boils at 373. Celsius is like, you are not helping your case here. He's like, but I am. Go ahead, subtract 373 from, or 273 from 373. You know, 3 minus 3 is 0, 7 minus 7 is 0, 3 minus 2 is 1. Oh, so it's still 100. That's a fairly easy number. Okay, we'll let you stay. So Kelvin is still hanging around. Now, Kelvin is basically only used for science and astronomy. Right, that's it. Now, why am I teaching you these 3 skills? Well, one is because I teach astronomy, so yay. The other one is because even though we're here in the United States and we use Fahrenheit, still the scientific stuff that is produced in the United States uses Celsius, so you have to be able to tell the difference. Also, if you want to travel to Italy or France or Mexico or like anywhere in the world, right, then you have to know Celsius. Alright, so here's an example. I grew up in a part of Canada that Canada didn't recognize really. I mean, we were Canada, but Canada's like, we don't really want you, and America's like, we don't really want you, but all of our news came from Detroit, right, which is, oddly enough, American. So we got all of our American news. We heard nothing from Canada. And so all of our temperatures are like, oh, it's going to be 86 degrees out, and you're like, oh, it's going to be a nice day, right? But my family, at least some of them, grew up in actual Canada, and they would say stuff like, it's so hot out over here, it's 30 degrees, and I'm like, okay, 30 degrees, like 32 is freezing, so how is it hot? Like, what kind of weird blood do you have, right? And then I realized, oh wait, they're in Canada, like actual Canada, so it's 30 degrees Celsius, not Fahrenheit. And so then I have to do the whole conversion. And how do you do that? Right here. Right? Fahrenheit is 1.8 times the Celsius plus 32. Now, I don't do 1.8 in my head, I am not that good, so I just round off to 2. And so I go, okay, 30 degrees times 2, that's 60, plus 32, that's 92. Like 92 degrees, yeah, okay, they're complaining it's hot, I get it, right? Now, if you look, 92 and 30, the 30 here is actually 86. So you can see there's a large error when you just round to 2, but it still gives you the idea of, oh, it's hot, right? And then for those of you that are math-minded, you can see where I got that from. For those of you that are not, don't worry about it. This is another equation that if you have Fahrenheit, it gives you Celsius. Okay? So Fahrenheit minus 32 over 1.8. Now, in your lab, I don't give you 1.8. I give you 9 over 5. Okay? If you are uncomfortable with fractions, just put in 1.8. That's fine. Okay? And then the last one gives you, if you have Celsius, how to convert it to Kelvin. Oddly enough, you just add 273. 273. That sounds familiar. Why does that sound familiar? Oh, yeah, that was ice melting on the Kelvin scale was 273. So you basically just take the Celsius and add the ice melting number.